So the main idea is to make AI accessible to everyone. If you have even a very low knowledge about machine learning, maybe you're just a Python developer or any other developer. So we're trying to make you possible to go there and find something that you can just grab and use for your own project.
Hello and welcome to the AI Master Group podcast, featuring the people who are building the future of AI in their work today. I'm your host, Jim Griffin. Today, I am very happy to have as our guest on the show, Pavel Iakubovskii, who's a machine learning engineer at Hugging Face. Welcome, Pavel.
Welcome, everyone. Hi, Jim. Very excited to be here.
I'm really happy to have you here as well. Can you tell me a little bit about your journey leading up to what you're doing now at Hugging Face?
Yeah, sure. Would you like a long story or it should be a short one?
An interesting story. It's interesting. Not everybody gets to be a machine learning engineer at Hugging Face. So you've obviously got something special there up your sleeve.
Okay, I will start a bit far. So basically, I was born in Kazakhstan, but quickly my parents moved to Russia, and I was living like all my childhood there. It was a really small city in the middle of nowhere, I would say. So near to the Ural Mountains. It was like 56 something 5-story houses there, and the only thing you could do there is to enjoy your time in school, basically. So I was a good school student, I would say that. Yeah, I was like all the subjects in the school, especially mathematics and physics, and participating in all kind of contests there. Yeah, in a school level, and then in a city level, I going up to the region level, but I was somewhere in the middle at that level. Yeah, never go to the country level. And also, like you cannot do, like, since the city was pretty small, I cannot do like too much in terms of maybe sport activities and something like this. So I was mostly like studying and enjoying different technical things. I was really liking robotics. At one point, our teacher started in robotics class, and I really enjoyed that time. This is where I first tried some programming skills. We have like simple UI interface, but still you could like implement some basic logic for your robot and make it follow your commands, basically. Yeah, and we also like build different robot there and participate in different competitions. Then also after the school, like I was always underestimating my skills, so going to some top university was kind of a dream for me, but still I was managed to do that. I go to one of the best universities in Russia, in Moscow. I mean, technical universities. It's called Bauman Technical University. But since I was living in the really small city, and the level of the professional orientation was really low at that place. So I didn't realize what I'm going to do in the future, which profession should I choose. So at that point, I choose the one of the simple one for me, as I think at that moment. I go to as a manufacturing engineer at the Bauman University. And I was studying fine there. I didn't feel like that was my passion at that moment. So I always liked more some software development, like programming. Yeah, we had just a little classes regarding the software development there. The rest was about the manufacturing, actually. Yeah, and I start feeling like, especially when I start working in that field and different manufacturing, I start feeling that I want to be like at some other field, which is more innovative, more fast. And because in university, in Russia, it was like not the best place. I mean, studying manufacturing, because they describe you different fundamentals about it, but they were like designed 100 years ago. I mean, it was really old. Yeah, there. And that is why I decided to make another step in my career, and I found that there is a small university which is not yet well known, but it has like starting growing fast, and the name is Caltech. It's located even not in the center of the Moscow, it's a bit outside. And that university actually has, at that moment, had a great connections with the broad universities. I mean, at that university, we had some connection to MIT University, and a few students even go to study in MIT for 3-4 months. Yeah, that was a kind of great opportunity to be there. And what is also really different from other universities in Russia is that you can actually decide which classes you want to attend. Yeah. And when I go to that university, even if I go for manufacturing, I really like switch from the first month to different topics. I take robotics classes there and start doing what I really enjoy. Yeah, that was a very awesome time there. I mean, people around, they were very ambitious, very smart. They like doing things, and I learned from them a lot. We had awesome professors there. Some came from MIT, some from other universities abroad, some from Russian universities. Yeah. This is how I basically make my career move from the manufacturing to software development. So during that time, I started already participated in different hackathons, participated in competitions. We even built a small company with my friends for developing some chat assistant. Yeah. And then, yeah, I graduated from it. I was good. I was great, I would say. So I have like all the highest scores there. Yeah, and start working as a software engineer in deep learning field. At that time was a huge demand in computer vision. It was a really fast development field, like ImageNet models. We're releasing like each month a new best score. Yeah. So that is how I choose basically to be a computer vision engineer and start working first in a local startup for processing satellite imageries. We were like processing a huge amount of data over the different countries, identifying and detecting buildings, roads, cars, providing some analytics around it. Yeah. And then since the COVID started and everyone goes to remote work, I started looking for another opportunity, and it was a great opportunity to start working with a Canadian startup in a dental field. Yeah, we were building there really cool. I still think it really cool software for dentists that able to identify, like analyze your X-rays when you came to the doctor appointment, and we were identifying like your teeth, your number of teeth, like if you have any missing teeth, if you have any crowns or fillings, yeah, and help doctor to fill out the form of the patient. Yeah, and also we had some software to identify different pathologies like caries, decay, or periapical lesions. But the hardest thing was like actually when you work in the medicine field, the hardest thing is like working with the data, because there is a really huge uncertainty in data. I mean, it could be a different kind of uncertainty, but if you like have one image, one X-ray, and you ask different doctors to analyze it, you will get like completely different results, like different diagnoses. So this was one of the main difficulties I was working on during this time. And the other thing was like to get a clinical study for all our devices, to submit it to FDA and get approval to be able to sell our product. So I was also involved in this process. It's like really long story, and you have to consider many things. But at some point it was like too many maybe paperwork regarding all these clinical studies we did, and I start feeling myself like I wanna be again at the cutting edge of the AI. I wanna explore new architectures, new opportunities. And I started like looking for another opportunity in my career. And just on LinkedIn, I found that Hugging Face is looking for a computer vision engineer. And I was excited. I had like, because for me it's a bit special. They're working on open source. I also had some open source projects which are pretty popular. So I do my best to fill the form, to put everything about my previous experience with open source there. And I got feedback from them. We had a series of interviews, and here am I, computer vision engineer at Hugging Face.
Wow. That is an amazing story, starting all the way back from living in a very rural setting in Russia, and then going up through a top university, and then finding another university that was up and coming with connections to MIT, realizing that factory was really not the interesting thing, pivoting more towards computer vision, then the dental, then Hugging Face. And one of the things that you mentioned early on in that story was really back in the rural days, you were talking about entering into competitions at the city level, at the regional level, and so forth. But one thing you didn't mention, and I happen to have noticed, is that you're actually a Kaggle competition master, my friend. So what does it take to be considered a Kaggle master, and how did you achieve that?
Yeah, thank you for the question, Jim. Back to the time when I was just graduated, maybe like still studying at the Skoltech, my second university for master. As I mentioned, many people were starting to participate in different activities. First, I was like participating in different hackathons. Like I maybe attend around 10 of them. With my friends. It was a fun time. But also, like hackathons, they are pretty limited in time. You cannot do too much through this time. And for deep learning, it's you had like longer experiment time usually. So I start looking for for different opportunities, and the Kaggle was one of the best platform at that time, and I suppose nowadays too. So I wanted to validate my skills basically. So I know that I can already build something, but I cannot estimate how good I'm in building things. That was one of the ways to start competing against other participants on the Kaggle. Yeah, and achieving this Kaggle master title was not an easy path. I mean, you have to be very basically you have to spend many time doing experiments on the competition, many time and many compute. But so this is a receipt to to get your medal on the Kaggle. So for that time, it was like I was studying or working all day. In the evening, I came back to home. It was like 7 p.m. or something, and you have another 6-7 hours to explore different papers, to different forums, different ideas, implement them and run your experiments. And the first thing you do in the morning, actually, you check your computer if the experiment goes well, what are the metrics. It was like really passion. I spent all my free time doing competing on the Kaggle. Yeah, and I suppose I participated like in 7 or 8 Kaggle competitions. There are people who do much more competition there, but at some point I realized that I have to stop and start doing other things, to like working on more real projects. It was enough.
But you won several, right?
Yeah. I mean, yeah, in Kaggle you have like, they have this medal, different type of medals. It could be gold, silver, bronze. I had like 2 gold medals, 2 silver medals, and 3 bronze. Yeah, but yeah, other than Kaggle, I also participated on other platforms. For example, there is a driven data platform. They don't have these medals. They have just first, second, and third places. And I was able to win. So I was the first among more than 1,000 people who submitted their solutions. Yeah.
Wow. Now, turning to Hugging Face, I noticed that Hugging Face recently hit an amazing milestone, over 1 million models there, including some very useful ones, including ones that I myself have used. Can you describe the main ways that most people use Hugging Face in their projects and the reason behind that?
Yeah, thank you. First, I would like to say that Hugging Face have like many projects inside, and the one project is a hub where basically all these models can be found by anyone. But I also want to mention that all these models, they are, so basically the hub, it's a community-driven project, because we, as a team in Hugging Face, we are like not putting all these models on the hub. So 1 million, it would be impossible for such a small team as Hugging Face is. So basically, you can find on the Hugging Face hub any kind of model as soon as anyone uploaded it to Hugging Face hub. But other than that, we are trying to somehow structure these models, make them more explorable, more visible to the community. So you can go there. There are like different texts of the model, different topics of the model. We're trying to like classify them to particular topics. It could be, for example, some models for NLP that you like for text generation, like most popular now, I would say like Llama or Gemma or any other model. It could be multimodal models combining text and images and audio, and of course, like for each modality also, for example, for audio to make speech recognition, or for vision, making object detection or image segmentation or image classification. There are even like some models for image generation. Like we had this library called Diffusers, and all the weights from this library are hosted on the Hugging Face Hub. So you can like take any of this model and generate your own image given a prompt.
You're listening to the AI Master Group podcast.
There are even like some models for image generation. Like we had this library called Diffusers, and all the weights from this library are hosted on the Hugging Face Hub. So you can like take any of this model and generate your own image given a prompt. But basically, you could find even like some really rare models. For example, you provide a prompt and it generates some 3D object or something like this. So many different applications could be. So I advise anyone to go there and spend some time just exploring the capabilities. So there, because it is community-driven project, you could find like any kind of model there.
Mm-hmm. And in particular, these projects that are there, it's not just about, oh, you find a model and then have a nice day, right? There's something more to it, the value proposition of Hugging Face. Am I thinking about that correctly?
Yeah. So we are trying to actually democratize AI. I would say that. So the main idea is to make AI accessible to everyone. If you have even a very low knowledge about machine learning, maybe you're just a Python developer or any other developer. So we're trying to make you possible to go there and find something that you can just grab and use for your own project. For doing this, we are like building our own libraries that are connected to the Hugging Face Hub, where we have this. For example, one of these most popular libraries is Transformers library from Hugging Face. It's called just this, Transformers. And we're trying to keep this interface of the library really similar between models of different modalities. So you can take either a model for speech recognition or a model for object detection that will have pretty similar interface, how to use it. So the idea is that you take this library and the weights from the hub, and you can instantly use this model to be able to build your own project. And other than that, we have not only Transformers library, but also other libraries that are integrated to the Hugging Face Hub. And we encourage the community to share the models, especially if you're a researcher. It's really nice way to put your model on the hub, and thus you can track actually how usable it is. Like you can track the number of downloads. I think that's pretty awesome. It's way better, I would say, than if you're like browsing GitHub, you find a cool project, and they have all like different interfaces. Weights are usually hosted on Dropbox or Google Drive, so you had to download it manually, put it in some folder, then understand how to install this particular project. And for Transformers, at least, we're trying to keep the number of third-party libraries we are depend on really low. Like there are many popular projects, but not that much trying to keep their dependencies clean. This greatly reduces the amount of efforts to start working with the library and running it almost on any environment.
That's true. It's very low effort to go ahead and use one of those. And you mentioned, rightfully so, that transformers are certainly one of the more popular uses there in Hugging Face at the current time. But aside from some of those more popular capabilities, are there any other projects going on over there that might not be on my radar yet?
Yeah, that's true. Like in Hugging Face, we have many projects running at the same time. Basically, we're trying to fail fast. I mean, anyone can start any project and put it on a GitHub and get some feedback. If the project is not popular, then it's just die in a few months. Yeah. And speaking about the amount of the projects we have, I would say that we have this stage of experiment when the project have like 3 months to become sustainable or just die, and maybe it's like 20, 30 each 3 months or half a year that's running in Hugging Face. Then we have these more or less sustainable projects. It's, for example, maybe you heard about LeRobot. It's a project for robotics, started with Remi Cadene, who is doing really great job. Like the project exists, I suppose, less than a half a year, and it's already have 7,000 stars. They are doing hackathons, many issues and PRs on GitHub. So we see like there is a huge community feedback, and the project's developing really fast. Also, we have, I mentioned Diffusers library, which is for generating images. We have parameter efficient fine-tuning to fine-tuning your models on smaller devices, so you don't have to fine-tune all the weights of the model. You can just put some adapters to the weights and fine-tune them. It will require just tuning maybe less than 1% of the size of the model, really efficient. So anyone can go with it and adapt a bit the model for their particular needs. Other than that, we have like auto-train to train models automatically in spaces. It's Hugging Face, another huge project where you can put your own demo with the GPUs and CPUs, so it's kind of hosting service. Yeah. Also, we have datasets. Maybe not everyone knows, but other than models, there are lots of datasets hosted on the Hugging Face Hub. Yeah.
Interesting. What kinds of datasets?
Yeah, they also have like different tags assigned. So it might be text datasets. One of the last I remember was released a fine web dataset. It's a really huge dataset. I suppose it's something 15 trillion tokens. So it's huge dataset. You can run basically training your base NLP model on that dataset.
Wow.
Yeah, and it might be computer vision dataset, it might be audio dataset. So it's also community driven. So maybe it's not that popular for now as Models Hub, but still you could find really useful data there.
Very interesting. Actually, it's also interesting that you're employed by Hugging Face, which means that they have money to pay you. But It seems like everything's open source and free to use. How do they generate revenue?
Oh, great question. Yeah. I had the same question when I came to the interview, and everyone I met, they are asking me the same question. But if you go to the Hugging Face hub, you could find that there are some extra capabilities of the platform. I mean, for example, we have Enterprise Hub for companies. You still can use like your free and open source version, but for huge companies, they need like extra capabilities. For example, single sign-on option, or they might want to have like specific management of their models. I mean, they want to, for example, manage different access of different groups of the company to different models, some advanced analytics, or I don't know, like hosting really huge models and running them on our resources, not our, but our partners' resources, like hosting them on AWS or Google Cloud or Microsoft Azure. So we also allow these options. Yeah. And for this is the one option, Enterprise Hub. Another option is like for usual users, you could get a Hub Pro subscription, and for $9 per month, you can get additional resources to run in your demos. So it will allow you to run your demo on the spaces when you want to showcase your model capabilities. And with this subscription, you will get the so-called zero GPU. So if anyone, it's kind of option of a GPU, but your application is not running on a dedicated server. It's just resources are allocated in time they are needed. Yeah, this is called zero GPU. And for this subscription, you also can get increased limit of their Hugging Face serverless API. So basically, many of the models that are hosted on the hub, they already could be used without even downloading them and installing them in your environment. So you can just use it as an API. Yeah, but there are some limits, of course, because we are spending compute for this. And yeah, with this subscription, you can just increase these limits. Yeah. Yeah. Other than that, two options with the hub. We also have kind of an expert support. So in case you're building some project with our tools, or you like struggling with running any of the huge models, you want to optimize it for production, you want to like quantize it, you want to improve the quality, you want to fine tune. We have some team who help customers to build better products. Yeah, and yeah, it was a Enterprise Hub subscription, expert support, and yeah, and we have like some also, as I mentioned, you can deploy any of the models, like almost any of the models that are supported by transformers. You can deploy them to AWS or Google Cloud, and then you use it as an API. It's deployed on a dedicated server. It can be scaled for your demand, and we also generate some revenue from this. Yep. I think that's maybe it. Maybe there are some other projects, but I'm not aware of it.
And those are very valuable things, that all of those things that you just described, they're satisfying a business need. So it's very sustainable.
Yeah.
Mm-hmm. So I've heard that Hugging Face has got a pretty unique approach to meetings. Is that true?
I would say that's true. Basically, it takes some time to adapt to everyone who start working in a Hugging Face, because we are really careful about meetings. Like, we don't have too much meetings. I would say we have really low amount of meetings. For example, I would say about the open source team. There are some teams in the Hugging Face that might have more meetings because they are, for example, working with the customers and they have more meetings. But in open source team, we have like one meeting for the whole team, maybe in month or in 2 months. So we're trying to sync with each other on Slack because Hugging Face is a remote first company. Many people are in different countries, in different time zones. So it's really hard to gather everyone for a meeting, and we trying to keep our communication in Slack fully asynchronous. So meetings are not that required in that case, and I suppose everyone is happy with it, so they can like really do their work very focused, not spending their time in meetings, especially if they're not like a huge demand in that. Yeah.
That makes perfect sense. First of all, meetings can be a big time waster. And then you've got all those different geographies with different time zones, and you can just get it done in Slack. But that one, a meeting every month or two, that would be nirvana for many people that I know. So I think that you have also a pretty popular library on GitHub, if I remember correctly. Can you tell me a little bit about that?
Yeah, I started with open source, pretty far away in time. Yeah, so it was started also when I was studying in university. I was competing in Kaggle competitions, and at that time it was really popular computer vision projects and competition. And the one thing I quickly noticed that people are copy pasting their code from one competition to another competition, from one repo to another repo. Like it was for the most popular model at that time was UNet. So it's an encoder decoder architecture, and people are trying to implement different encoders. For example, you want a UNet with ResNet, you want a UNet with Inception or VGG model. They were popular at that time, and I basically took this idea and implement the simple library that allow you to choose encoder from a list and decoder, and take one of the decoders. So combine two things. It was a really simple interface. I think that was one of the keys to success. Another key was to be able to load pre-trained weights. Actually, I saw also another libraries, but they provide you just with the code of the model. But to have a faster convergence, to save compute and time for experiments, it is great to have pre-trained model on ImageNet. So it was another key feature of the library, and this is basically how it goes. I made the first version with the Keras. At that time, it was the most popular framework, and I start getting feedback really quickly. I mean, I implemented it. I never talk about it, never use it. I just put it on GitHub, and like in a few months, I get maybe 50 stars on my repo. So it was somehow promoted by GitHub, I guess. So people just starting finding the library and using it and leaving issues. Then I started using it for Kaggle competitions, and many people also started using it. So it quickly became popular. then then I have also like a few libraries. First of all, I re-implement the same library in PyTorch, which is now one of my most popular libraries. It has almost 10,000 stars on GitHub. Also, at that time, I was like, the things start changing. I mean, it was like two competing frameworks, Keras and PyTorch. Keras with the TensorFlow backend, and some models were released with the weights on PyTorch, and other models were released with the weights on Keras. So I started basically converting and implementing some models on different frameworks. Like one of the most popular, I suppose, I implemented at that time was like ResNet models. ResNet 34 was released on PyTorch, but never ported to the Keras. So I just converted weights and we wrote the architecture, and it was one of the also most popular libraries. Another was EfficientNet, also implemented in Keras and ported from PyTorch. Yeah, and for Kaggle competition, you want to take the maximum from your model. And one of the technique was to apply a test time augmentation for your vision model. So basically you took your image, for example, for classification, you pass it as is, then you for example, flip it horizontally, and you again doing a prediction. And then you'll just average the probabilities of the model. And this usually allows you to get a bit higher score. So I implemented this library, which basically wrap your model with a simple wrapper that under the hood doing these flipping techniques, averaging of the probabilities, and providing you the result. So it's called TTA wrapper, I suppose, and TTH for the PyTorch. Yeah, this is like the most popular libraries I've ever had on my GitHub. I suppose altogether now they are around 20,000 stars.
Wow, that is popular. And for good reason. I mean, you really took the time to build something that really has fundamental value that people need. This has been amazing, Pavel. I'm so glad we had a chance to connect. We've talked before. We met in Madrid, but I really didn't. I didn't know all the things that you just shared. So if people want to get in touch with you and maybe collaborate or follow up on some of the things that you've mentioned, how should they do that?
They can get in touch with my LinkedIn account. I have account there, so it's Pavel Iakubovskii. You could find me. Maybe we can put some link in the comment on the video to share it with the people. Yeah, also you could write me basically on a GitHub. So you could find out one of my projects. There is an email there, so you could write me directly there. Yeah.
Okay, either of those two ways. And yes, I can do that. I can add what you ask on comments, definitely. Well, once again, Pavel, this has just been an amazing conversation. Very interesting conversation from end to end, full, rich of detail. So thank you very much. I really appreciate it.
Thank you, Jim. Was really excited to be here and hope you like it. Yeah.
You've been listening to the AI Master Group podcast. I'm your host, Jim Griffin. Until next time, stay curious and stay in front.